rolling.
Barry?
Okay, yes.
Running out of space in my binder.
Are you? All right, so I'll brainstorm with you after class, okay? So, guys, you have to be quiet now. Okay? I have this on, and I'm hearing a lot of people talking. So, Serena, you got to be quiet now. Serena, you have to be quiet now, okay? All right, so I hope this is seeable. Well, anyways, on the video, it's a little hard to tell because there's a light shining right there, but it says writing equations. A while back, I taught you guys that there were 3 useful ways to write equations. Does anybody remember what they are? Okay, Nathan.
Standard.
Okay, there's standard form.
There's
y-intercept.
point slope.
Something like that.
Point slope.
And the y equals mx plus b.
And which is called the
Wait.
Slope intercept.
slope intercept, right?
That's what I said.
Okay, so those are 3 useful ways. There's a billion ways to write equations, right? Those are the useful ones. Because by using these equations, as you now know, they're really easy to graph, right? Whereas if I did, guys, Gabe, like if I wrote these, if I wrote it in a different form that's not in one of these, it would be a lot harder to graph, right? So the beauty of this is we know how to graph them. We can graph them all very quickly, very easily, right? Now, what we've talked about graphing so far. Now I'm going to be talking about what if I gave you data and I asked you to write an equation from that data. So some of this is really easy, and then there's one aspect that we haven't learned yet, and we're going to talk about that today. But let's try. So in general, if I give you data and I ask you to write an equation, you're probably not going to use standard form. Okay? These are the 2 that you're probably going to use. The point slope and the slope intercept. Right? Now you can convert into standard form from those very, very quickly and very easily. So if they asked you to do something and convert it to standard form, it wouldn't be that hard. But most of the time, we're going to be dealing with these for what I'm going to teach right now, okay? Either point slope or slope intercept. So here's an example. So here's example number 1. Write an equation. That has a slope of 1/2 and crosses, that doesn't look right. Is that crosses?
Looks like crosses.
I know.
That's what I put. That's crosses.
Okay, and crosses the y-axis. I'm writing uppercase and lowercase. I can't do that. The y-axis at -3. All right, that's your first problem. Write an equation that has a slope of 1/2 and crosses the y-axis at -3. What information did they give us?
The y-intercept and the slope.
They gave us the y-intercept and the slope. So which of these 2 would you use? Slope intercept. What is that formula? That formula is y equals mx plus b, right? All right, so we write our formula. We write y equals mx plus b.
Y equals 1/2 x minus 3.
Exactly. So our slope is the m, right? M for mountain, mountain slope, right? M, right? So that's going to be 1/2. So we have y is equal to 1/2 x. You got to have that x in there, right?
Yeah.
And then your y-intercept is what, Gabe? -3? Yes. Right. -3. Right. right?
That B looks like a 6.
So that's pretty straightforward. Oh, sorry. I'm right in everybody's way. Sorry. Now I'll get in your way for a while. All right. So write an equation that has a slope of 1/2 and crosses the y-axis at -3. So where it's crossing the y-axis, right, at -1, 2, 3, that is the y-intercept. So it would be slope-intercept form, right? Pretty straightforward. Fist to 5. You guys get this? All right. Yes? All right. All right, so now I'm going to do a few. I'm going to
10D1.
I'm going to leave that, and I'm going to change this, and I'm going to change this. All right? And it's slope of 2/3, and x crosses the x-axis, or the y-axis at 14. All right, what's the equation? Liam, what's the equation? So y equals, what's my slope? M is my slope. 2/3. Okay, I got to keep my x next to it. And what's my y-intercept? Liam. Yes, because it's crossing my y-axis. Plus 14. We're done. Look at how fast and easy that is. That's amazing. Right? Isn't that amazing?
Is that the data?
The data is, they gave me a slope, and they gave me a y-intercept. The y-axis, it crosses the y-axis at 14. So that's my data. Okay, does that make
Now
sense?
let's do one with the point in the corner.
What?
Let's do one with the point in the slope.
All right. So, does anybody need any more examples of this kind? You guys feel like you get it?
Yeah, I get it, but I have a question.
Yes, Liam.
Are we gonna get like word problems of these, or like show the increase or decrease of like this company's progress or something?
We will eventually, but not yet. Today is not word problems. Today is this kind of stuff, and also you'll learn the other one in a second. Okay. So can I erase this?
Wait.
Yep.
Shall we do one more?
Wait.
Let's do one more. Let's do one more.
Still don't erase it.
Don't erase it. Okay. I won't erase it. All right.
Do the other one.
I'm going to do one last one. Can I erase this part? 2/3 and 14. All right. All right, here we go. A slope of -11/15, and it has a y-axis of 2,562.8.
2,562.8.
Yes.
I can't even write that.
So what is my equation?
Got it.
So,
Oh, I got it.
all right, Indu, what is it? Y equals,
Isn't it -11?
yes.
-11/15 x plus 2,562.8.
You got it, right?
That would be a big...
Pretty straightforward. Good job. All right. So that was just another example.
Yeah, that would be like...
It would be like,
It would be a very large...
yeah, it wouldn't be very fun to graph, but it would be possible.
We should
Um,
We should do that again.
Okay, can I erase this? You guys understand this, right? All right.
Wait.
Don't erase what? I want to erase it.
You can erase it. Yeah, you can erase it.
I can erase it. Okay. They look good on you, dude. Seriously. All right. All right, so wait. Now here's another one. Here's another problem. Problem number 2. Write an equation. I shouldn't have erased that whole thing. I could have just rewritten. Write an equation that has a slope of 3 and passes through. I'm going to abbreviate my through by THRU, okay? Passes through.
Gary, you don't really have to tell us that. Right.
Well, I have to say it because if Dina sees it, you know, and says, "Oh my gosh, the math teacher doesn't know how to spell through." All right. 7 comma negative 1. That is, okay, so what did they give us?
The point and this point slope.
Point and slope. And so we would use which form? Yeah, point slope. There is a way to do it using slope intercept, but I won't teach that. I'm going to just teach you the point slope right now.
Can you teach us both?
How to do it with the slope intercept? I can show it both ways. So,
I did it.
all right, so what would I do? I write my equation. Remember, what is it? Y
Plus 1.
minus y1. I want my formula first.
1 minus y1 equals m times x minus
X
x1.
sub 1.
Okay, so I'm going to rewrite that here. Y minus y1 is equal to m times x minus x1. All right, so
I remember these ones.
I am going to plug this information in. I've got, what am I going to plug in? What is this? What is my y1 in this point?
Negative 1.
All right, so I'm going to go y minus a negative 1,
No, it's plus 1.
right?
So positive
Minus a
1.
negative, right? Y'all see that? It's going to be positive, right? I'm going to make that into a plus 1. Equals, what's my slope?
3.
3, parenthesis,
X minus 7.
x minus 7. Good. Piece of cake, right?
Yeah.
Piece of cake. All right. So, can I erase it?
Yeah.
No, not no. Wait.
Okay, write an equation that has a slope of 3 and passes through 7 comma negative 1. We're done. I mean, look, that was so easy. We had the point and we had the slope.
Is it possible to simplify it?
Is it possible to simplify it? That is in simplest form for a point slope formula. But you could very easily turn it into slope intercept formula.
Oh, yeah.
Remember, slope intercept, all it says is y equals. So you would do 3x minus 21. You'd subtract 1 from both sides. So y is equal to 3x minus 22, right? Because you're subtracting 1, right? You'd have to multiply this out and then subtract the 1. So it says y equals. And then it would be in slope intercept. You guys want to see how to do it in slope intercept form?
Show.
All right, I'm going to do this in a different color. I'm going to do this in orange. if
Is
this
it going to be
works.
the same problem?
Same problem. I just want you to see it for a second. So, because some teachers, when you get into high school, ironically, some teachers won't let you use the point slope formula. Don't ask me why.
That's dumb.
It's kind of dumb, but that's what they. So some teachers prefer you to use this method I'm going to show you now. I personally prefer the point slope formula, and if they ask for it in slope intercept, I would then just multiply it out and convert it to slope intercept. But this is how you could do it. If you were in slope intercept, y is equal to mx plus b. All right, what did they give us? They gave us the slope, right? They gave us, in the original problem, they gave us a slope. So they gave us m equals 3, right?
Do like 7 times negative 1 times the slope.
Hang on. So we're going to use this formula. They gave us 3 things. They gave us a slope, and they gave us an x, and they gave us a y. Do you see that? What's my x? 7. What's my y?
Negative 1.
Negative 1. So look, I could plug all of these into this formula, and what would be the only thing I wouldn't know?
B.
B. And so as long as there's just one unknown, I can solve for b, and then I will know my equation. Right? So watch this. Let's plug that in. Set y is negative 1. Negative 1 is equal to,
Wait, I thought x was negative 1.
it says y is negative 1. Right?
No, what if they're reversed?
What?
Never mind.
So yeah, so that, remember it's x comma y. So that's x is 7, y is negative 1. So negative 1 is equal to, the slope is 3 times 7 plus b. So negative 1 is equal to 21 plus b. What could I do? Subtract 21, right, from both sides? right? Then I have b is equal to, what do you mean no? Who's saying no?
B is equal to negative 22.
b is equal to negative 22, right?
Oh, 22.
So look, I now figured out, I know all my possible, I know that when I'm at this point, at 7 comma negative 1, I figured out my b is negative 22.
So it'd be negative 1 equals 3.
So wait. So now our final equation will have a y in it and an x in it. I'm not going to include the 7 and the negative 1 now. I'm going to go back to an equation that has a y in it and an x in it. So it's going to look like this. I'm going to rewrite this, mx plus b. I want my y to stay y equals, I want my slope to be the slope. What is it? 3. I want my x to say an x. And then I want my b to be what I discovered.
Minus 22.
-22.
So the y equals 3x minus 22.
Yeah. Now that is not very hard to do. But this is way easier. You see the difference? I just plug him in and I'm done. If I use point slope formula. If I use slope intercept, I have to plug in all these points to find b. It doesn't take very long. And then once I find b, I go back and I write my equation without the 7 and the negative 1, just with y and x. Y is equal to 3x minus 22. This to 5. Do you guys get that? Does it make sense to you? It's a little trickier, right? It's a little trickier. How many people prefer this method? I'm just curious. For putting it in.
Yeah.
Isn't that, it's a little easier.
Yeah, it makes more
And so
sense.
if I did that and they said they wanted it in slope intercept form, I would just do this. Y plus 1 is equal to 3x minus 7, right? I would do my distributed property. Y, I know I explained this, but I'm going to show you guys. 3x minus 21. I'm going to subtract 1 because I want to say y equals. Look at this. Y is equal to 3x minus 22.
Oh snap.
Right? Pretty fast. Pretty fast.
It's easier and it makes more sense.
Yeah. So, you know, it just depends on who you get in high school and what math teachers have their preferences, and it's not that big a deal either way. You can do it either way. No problem.
Teachers can be evil.
Now, I'm going to throw a curveball at you.
Yay!
I can't catch a curveball.
I'm going to erase this stuff.
I like curveballs. They never hit me. It's not bad.
I know.
Oh. Okay. Write an equation. All right, here we go. Write an equation. I'm just using what was already there. That passes through 2, 6 and 8, 2. Write an equation that passes through 2, 6 and 8, 2.
I like how he's going through. Couldn't we do this in standard form?
That passes through what?
What did they give us? What did they give us?
2 points.
2 points. But wait, up here it says I need a point and a slope. I don't need 2 points. 2 points. I only need 1 point and a slope.
Wouldn't you just be able to just be like graph it and then like 2, 6, and then 8?
Well, that's an interesting idea. Let's try that. Let's try that. Let's graph.
Is there an easier way?
Let's try this. I think that's a brilliant idea. Let's try it. So I'm going to try to do this fairly accurately, right? Fairly evenly, if I can. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6. Okay. So 2, 6. I'm going to go over 2 and up 6. Broom, broom. Right?
What about
Right? And then I'm going to go over 8 and up 2. Right about here, right? Somewhere in there. And so you're saying, Hunter, you're saying that I could just graph it and then I don't have a ruler, do I?
just draw the line? Oh, there you go.
Right? And then I just draw my line,
Wait a second, but why is it
Right.
down?
and it's right? So if I did that, then what could I find out?
Slope.
I could find out a slope. How would I find my slope?
Do down and then over as much as you can.
All right, so this is at 2, right? Let me just see. That's there, right? And this is,
That'd be like 2/6 would be
so
slope.
from here,
Yeah, 2/6.
would I have to go, would it be a positive or negative slope, first of all?
Negative.
Negative, because I'm going to go down. So I'm going to ask myself, what is the slope to go from this point to this point?
It's down
Right?
4 over.
So I'm going to go down 1,
Yeah, negative.
No,
or
negative
2,
6.
3, 4.
Yeah.
So I'm going down 4, and I'm running,
over.
let's see,
Over.
Right.
Over 6.
1, 2, 3, 4, 5, 6.
Yeah, over 6.
Over 6. Now, that's my slope. Now, can I simplify this slope?
Yes.
Yeah.
As 2 goes into this, negative 2/3, right? So now could I write my equation?
Yeah.
How would I do it?
Oh no, you wouldn't. Never mind.
I have a slope and I have 2 points. I could just use either point. Right? So remember my,
They both have
so
the same.
y minus y1, this is my y1, this is my x1, right? So y minus 6 is equal to negative 2/3, negative 2/3 x minus 2. Look at that. That was one of them. I could use this point too, and they would look very different. Y minus 2 is equal to negative 2/3 x, where am I? X minus 8. Right? Look, those are identical. They don't look identical. They don't look identical, but they're identical.
Wait, no, but if you start
That was like.
Wait, shh. What? Wait.
that's
Guys, there's questions on the floor. Okay, questions.
would that slope work from x? Oh wait, never. But wait, if you did that from x to x8 2, it wouldn't pass through 6 to 6.
Okay, so what I'm telling you right now is this equation and this equation are identical. They don't look identical because they're written based on a particular point, right? So watch, I'm going to show you something. Watch this. I'm going to prove that they're identical. I'm going to do this. Oh, do I have to? Yeah, what the? Except, I don't know if I want to prove this particular one.
Why?
Oh, what the heck? Who cares?
No, just not on that graph.
Y minus 6 is equal to negative 2/3
I'm not saying they're not
x minus 2. So I'm going to just distribute, right? Y minus 6 is equal to negative 2/3 x plus 4/3. I'm going to add 6. So why is there so much noise? So 6 4/3 or 7 1/3, right? So plus 7 1/3. All right, that was this one. Let's try this one. Y minus, oh, I guess it's right there, so I'll just use that. So y minus 2 is equal to negative 2/3 x plus 16/3, right? And I'm going to add 2. So I get y is equal to negative 2/3 x. Now what is 16/3?
Like 5 times.
So 5 1/3, right? 5. What's 5 1/3 plus 2?
7 and 1/3.
7 1/3. Look at that. When I converted these to slope-intercept form, they're identical. Exactly the same thing. But because the point-slope form goes through a specific point, it's going to each point it goes through is going to have a different looking equation. Isn't that weird? But really, it's exactly the same equation. Always. Right? Always. I can't believe this lecture is not going where I had planned. So to give you the homework I was going to do. But when does this end?
Now.
Yeah, like right now.
Yeah, like right now. Seriously.
I didn't hear a bell. Did you hear a bell, Dina?
Yes.
I didn't hear a bell.
Please ring the bell.
I didn't hear a bell.
Yes.
I go by bells. Right? So,
Ring the bell.
so wait, let me.
Ring the bell.
I don't like you.
Oh, well then.
Oh, I thought she was going. Okay. So watch. You guys look.
That was me. You hurt my feelings.
I guess I will continue this tomorrow.
Who is
okay?
your hero?
Yeah!
Tina!
If I tap you, if I tap you about your logs, please make sure I get